Hello everyone, in this video I explain how to determine the coefficient of static friction.
Friction. Friction is a force which opposes the motion of a body when it is in relative motion. We are studying the relationship between force of limiting friction and normal reaction and finding the coefficient of friction between a block and a horizontal surface by plotting a graph. Principle. The limiting friction is the least force required to move the body from rest. If F be the limiting friction and R be the normal reaction, then F is directly proportional to R. Therefore, F is equal to mu R, where mu is called the coefficient of friction, which is a measure of friction based on the types of material that are in contact. Note down the total mass added to the weight hanger and multiplied by acceleration due to gravity G, which gives a force of limiting friction F. The normal reaction R is given by the mass m of the wooden block multiplied by acceleration due to gravity G. The coefficient of the static friction is then calculated by the equation mu is equal to F divided by R.
What are the apparatus that we need? So, wooden block with hook, 20 gram and 10 gram. Actually they are different mass. Horizontal plane with fitted horizontal plane with frictionless pulley in one end, spring or digital balance, thread. That is a wooden block rest in equilibrium on a horizontal plane. What will happen if we put the weight here? So this will be a tension. When the tension increases, the friction force in opposite direction, it will be increases. Now when we increase the tension, so the friction force increases. Before that wooden block moves, this is called limiting friction. So the way is that we increase the weight on the hang, we increase them before to move. And then we calculate the tension. This tension equals the mass of hanging multiplied by G. And we calculate also the normal reaction, which is equal to the weight of the wooden block. We start the experiment. First step, we find the mass of wooden block by using digital balance. So the mass of wooden block, it's 200 gram. R, it is M, this is M1. R equals M1 times G. Let G equals 10 meter per second square. So R, the normal contact force, equals mg. 200, we change 200 to kilogram because it's a gram. The normal contact, it's 2 newton. Now we start to put slots on the hanging plate and observe the wooden block. We increase the mass of hanging plate and observe the wooden block, increase it, but take care because we need just before to move. So we increase 10 gram and we observe also, increase another 10 gram. Now start to move. Okay, so we remove this 10 gram and return the block back, and then we replace 10 gram by little amount of mass. So we replace 10 grams, the last one, by little amount. Just we need limiting friction just before to move. So this is a little amount. Also it moves. So we decrease its mass also by This one, it's more slightly this, not moving. So we add another one. Yeah. So this is the weight. This is the total weight. So we find the mass of the hand with slots. So we find its mass. This is the total mass of the hand. We divide by 1000 and multiply by 10 to get the friction. The friction force, which is equal to the mass of the hanging, equal to this, the mass of the hanger with slots, it is 0.76 Newton. We repeat this experiment. We move the mass and we repeat the experiment and we put more slots on the wooden block. We find the mass of the wooden block includes the slots, the coils. So, we have 232.9. So the total mass is 232.9. For the total weight of the block and the mass is 232.9 gram. We change it to kilogram, 2.3 Newton. Now we add mass to the hanger. So be careful and observe the block. Okay, start to move. We add slots to this one. Yeah. Now we find the total mass in the second case. This is the second trial. We complete the third, the fourth, and fifth trial. We finish to take the 5 trials. Here, plot the graph of normal reaction R versus limiting friction F. We start to draw the graph. On the horizontal axis, we represent R, the normal contact force. On the vertical axis, y-axis, represent the friction force, both in Newton. 0. Now look at that values we got before. So for R, the maximum value is 3.1. So we divide this one into 0.5. And the maximum value of the friction force is 1.25. So you can say 0.1. This is the graph, x-axis and y-axis. We plot the points. Down, okay, here from 0 to 0.5. So 10 dashes down equals 0.5. So 1 dash equals 0.05. So each 1 dash represents 0.05 Newton. Now, the first value, we represent this column and the last column. So this one here, it is 2 Newton here. So R, it's 2 Newton, and F, it is 0.76. In the vertical one, each 1 dash here in the vertical, it is 0.01. Each 1 dash on the vertical line is 0.01. So we need to represent 0.76. So at 2, we go up to 0.76. So approximately it is 0.8. So we round this to 0.8, 0.76, 0.7 and then 6, it's okay. So we 6 dashes after 0.7, 0.7, yeah, so it's here, 0.76. The second point, it's 2.3. So we plot the points, we draw the best fit line. How to draw? It is a line in between the points, such that the number of points up to the line equal the number of points down to the line. So this is here, the best fit line. So this is the best fit line. We draw a triangle. We find the slope y2 minus y1 over x2 minus x1. So this is the values y2 minus y1 over x2, y2 minus y1 over x2 minus x1. We calculate this value. 0.41. So this is the coefficient of static friction. So the coefficient of static friction, it is 0.41. We answered that paper. He said, what is the relationship between R and F? It's a direct relation. Direct relation. Use plotted graph to determine the coefficient of static friction. Mu s from the graph, which is equal to the slope, it is 0.41. What are the sources of error in this experiment? The sources of error is that use the different types of mass from 20 gram to 10 gram. But maybe we have in between. Now, what is the conclusion? Why we did this experiment? What is the aim of this experiment? To determine the coefficient of static friction. So, if F is the limiting friction and R is the normal contact force, so the limiting friction F between the wooden block and the plane is directly proportional. So the relation between the limiting friction F and the normal contact force is a straight line. Its slope equals the coefficient of friction. I hope you understand this experiment. Thank you.